Now, let's try to use all the three theorems that we've just learned to solve some sample questions. This is the first one. On this diagram, your job is to find the value of x. Do you see two angles on this diagram? The first one, angle AOB, is angle at the center. And the second one, angle ACB, is an angle at the circumference. So by recalling the first theorem, you can say that angle AOB is twice angle ACB. That means the value of angle x will be half of 102 degrees, which is 51 degrees. Example 2, something similar. Again, you have angle AOB, which is angle at the center, and angle ACB, which is angle at the circumference. Using the same theorem, you can say that angle at the center, which is AOB, is twice angle at the circumference, which is ACB. So the value of x should be half of 80 degrees, which is 40 degrees. Simple, right? Now let's try the third one. See if you can figure it out yourself. Can you find the value of x here? Again, angle COA is angle at the center, and angle CBA is angle at the circumference. So by first theorem, the value of x should be double of 42 degrees, which is 84 degrees. Example 4. This is slightly different, but it's not difficult at all. Can you find the value of x? The very first thing you need to realize in this example is that angle ACB is inscribed within a semicircle. So, utilizing theorem 2, you can tell that the size of angle ACB is equal to 90 degrees, simply because it is an angle in a semicircle. Example 5. Now we have two variables, x and y. Do you know which one to find first? Let's start by finding the value of y here. How do you find the value of y? Looking at this triangle, COB, do you realize that this is an isosceles triangle? Yes. OC and OB are both the radius of the circle, which means angle y will be equal to 40 degrees because they are base angles of isosceles triangle. And what about x? Let's see here. We have angle AOC, which is angle at the center, and we have angle ABC, which is angle at the circumference. Again, recalling theorem 1, angle at the center is twice angle at the circumference, which means angle ABC will be half of 110 degrees, which is 55 degrees. From there, you can calculate x easily, simply by subtracting 55 with 40 degrees. You'll get 15 degrees as the value of x. The last example, now we have three variables, x, y, and z. Can we solve them in order? Let's start by finding the value of x. Can you figure out the size of x? If you look at this angle, angle ADB and angle ACB, they are both angle at the circumference, and they are located in the same segment. So recalling theorem 3, we could say that angle ADB is equal to angle ACB, which means x is equal to 60 degrees. What about y? To find y, you simply need to look at this triangle. You already know the size of its two angles, which are 60 and 80, which means the size of the third angle can be found simply by subtracting 180, which is the sum of angles in a triangle, with 60 degree and 80 degree. There you go. You get y equals 40 degrees. Z is the last one. How do you find the size of z? Again, let's look at this angle. DAC and DBC. They are both angles in a circumference inscribed in the same segment. Both angles are drawn out of the same 2 points, which are D and C. So utilizing theorem 3, we could claim that BAC is equals to DBC, and that means Z is equals to Y, which is equal to 40 degrees. This example 6 concludes our lesson for today. So I hope you learned something today. And what I advise you to do next is to do some practice questions so that you can use all the 3 theorems with ease and with confidence. Shall we do that? Thank you for watching my lesson.